In operating rooms, switches, outlets, and any other devices operating over 10 volts must be located not less than 5 feet above the floor, as mandated by NFPA 99, Healthcare Facilities Code, Article 517, Electrical Systems. This elevation requirement is intended to reduce the risk of accidental contact and potential hazards associated with electrical devices in these critical environments. It's crucial to adhere to this standard to ensure patient and staff safety. Furthermore, in rooms where flammable anesthetics are stored or used, stringent electrical installation protocols are essential. According to NFPA 99 Article 501, anesthetizing locations, all electrical equipment and wiring must comply with specific requirements. Firstly, switches, outlets, and equipment disconnects must be housed in explosion-proof enclosures. These enclosures are designed to contain any internal explosions, preventing ignition of flammable anesthetics in the surrounding atmosphere. Secondly, rigid pipe or conduit is mandated for all electrical wiring within these locations. Rigid conduit provides a robust and secure pathway for electrical conductors, minimizing the risk of damage and potential sparking. Thirdly, conduit seals are imperative at all points where conduit enters or exits an explosion-proof enclosure. These seals prevent the passage of flammable vapors or gases through the conduit system, maintaining the integrity of the explosion-proof environment. Finally, no ductwork, mechanical piping, or other systems should traverse anesthetizing locations. This prohibition aims to eliminate potential sources of ignition or pathways for flammable substances to spread. These comprehensive requirements are in place to drastically reduce the risk of fire or explosion in areas where flammable anesthetics are present, safeguarding patients, medical personnel, and the facility itself. Adherence to NFPA 99, Articles 517 and 501 is paramount in ensuring a safe and secure environment within operating rooms and anesthetizing locations. Explosion-proof enclosures are a critical component in hazardous locations where flammable gases, vapors, or dust may be present. These enclosures are designed to contain any internal explosion, preventing it from propagating to the surrounding atmosphere and igniting external flammable materials. The construction of explosion-proof enclosures involves robust materials and precise engineering to withstand the pressures generated during an internal explosion. Typically, they are made of heavy-duty metals such as cast iron, steel, or aluminum, with thick walls and tightly fitted joints. The enclosures are designed to vent hot gases and flames through specifically engineered pathways, cooling them and reducing their pressure to a safe level before they exit the enclosure. These pathways, often referred to as flame paths, are carefully designed to ensure that the escaping gases do not ignite the surrounding atmosphere. Common types of flame paths include threaded joints, flat joints, and labyrinths. The dimensions and tolerances of these flame paths are precisely controlled to meet stringent safety standards. Installation of explosion-proof enclosures requires careful attention to detail. All joints and connections must be properly tightened and sealed to maintain the integrity of the enclosure. Conduit entries must be sealed with approved sealing fittings to prevent the passage of flammable substances into the enclosure. Regular inspection and maintenance are essential to ensure the continued effectiveness of explosion-proof enclosures. This includes checking for any signs of damage, corrosion, or loose connections. Any defects must be promptly repaired to maintain the enclosure's ability to contain an explosion. In addition to explosion-proof enclosures, intrinsically safe systems offer another approach to electrical safety in hazardous locations. Intrinsically safe systems are designed to limit the energy available in electrical circuits to a level that is too low to ignite flammable materials. This is achieved by using specially designed components and circuits that restrict voltage and current to safe levels. Intrinsically safe systems are often used in instrumentation and control applications where it is impractical to use explosion-proof enclosures. Rigid conduit is a type of electrical raceway that provides a robust and durable pathway for electrical conductors. It is typically made of steel or aluminum and is available in various sizes and thicknesses. Rigid conduit is commonly used in industrial and commercial applications where mechanical protection and resistance to corrosion are required. Installation of rigid conduit involves cutting, threading, and assembling sections of conduit using threaded fittings. Proper support and grounding are essential to ensure the safety and reliability of the conduit system. Conduit seals are used to prevent the passage of gases, vapors, or liquids through conduit systems. They are typically installed at the boundaries of hazardous locations or where conduit enters or exits enclosures. Conduit seals are filled with a sealing compound that tightens to form a barrier against the passage of fluids. Proper installation of conduit seals is critical to maintaining the integrity of the electrical system and preventing the spread of hazardous materials. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in various types of locations. The NEC is updated every 3 years to reflect changes in technology and best practices. Compliance with the NEC is essential to ensure the safety and reliability of electrical systems. Article 501 of the NEC covers electrical installations in Class I hazardous locations, which are areas where flammable gases or vapors may be present. Article 517 of the NEC covers electrical installations in healthcare facilities, including operating rooms and anesthetizing locations. These articles provide specific requirements for wiring methods, equipment, and grounding to minimize the risk of electrical hazards. In healthcare facilities, patient safety is paramount. Electrical systems must be designed and installed to minimize the risk of electrical shock, fire, and explosion. Grounding systems must be carefully designed to provide a low-impedance path for fault currents. Equipotential bonding is used to minimize voltage differences between conductive surfaces in patient care areas. Regular testing and maintenance of electrical systems are essential to ensure their continued safety and reliability. Healthcare facilities must have a comprehensive electrical safety program in place to address potential hazards and ensure compliance with applicable codes and standards. Understanding the specific requirements of NFPA 99 and the NEC is crucial for electrical professionals working in operating rooms and anesthetizing locations. Proper design, installation, and maintenance of electrical systems are essential to creating a safe and reliable environment for patients and staff. Additional safety measures such as regular inspections, staff training, and adherence to established protocols can further enhance electrical safety in these critical areas. The integration of these practices ensures a comprehensive approach to minimizing risks and maintaining a secure environment for all. Continuous monitoring and evaluation of electrical systems are also vital to identify potential issues before they escalate into hazards. Implementing advanced technologies such as predictive maintenance can help detect early signs of equipment failure, allowing for timely repairs and preventing unexpected downtime. Furthermore, fostering a culture of safety among healthcare staff is essential. Regular training sessions on electrical safety procedures and the importance of reporting any electrical anomalies can empower employees to actively participate in maintaining a safe environment. Collaboration between electrical professionals, healthcare administrators, and staff is key to ensuring that electrical safety protocols are effectively implemented and consistently followed. This collaborative approach promotes a shared responsibility for maintaining a safe and reliable electrical system within healthcare facilities. The use of uninterruptible power supplies, or UPS, is also crucial in operating rooms and anesthetizing locations. UPS systems provide backup power in the event of a power outage, ensuring that critical medical equipment continues to function without interruption. These systems are essential for maintaining patient safety during surgical procedures and other critical medical interventions. Regular testing and maintenance of UPS systems are necessary to ensure their reliability and effectiveness. In addition to UPS systems, backup generators are often installed in healthcare facilities to provide a longer-term source of backup power. Generators can supply power to the entire facility or to specific critical areas such as operating rooms and intensive care units. Regular testing and maintenance of generators are essential to ensure their readiness in the event of a power outage. The design and installation of electrical systems in operating rooms and anesthetizing locations must also consider the potential for electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive medical equipment, leading to inaccurate readings or malfunctions. Shielding and filtering techniques can be used to minimize EMI and ensure the reliable operation of medical equipment. Regular testing and monitoring of EMI levels are recommended to identify and address potential interference issues. Furthermore, the selection of electrical equipment for use in operating rooms and anesthetizing locations should be carefully considered. Equipment should be specifically designed and certified for use in these environments to ensure its safety and reliability. Equipment should also be regularly inspected and maintained to prevent malfunctions and ensure its continued safe operation. The use of isolated power systems, or IPS, is another important safety measure in operating rooms and anesthetizing locations. IPS systems isolate the electrical supply to medical equipment from the main power grid, reducing the risk of electrical shock to patients and staff. IPS systems also provide a means of monitoring the insulation resistance of the isolated circuit, allowing for the detection of potential ground faults. Regular testing and maintenance of IPS systems are essential to ensure their continued effectiveness. In addition to the technical aspects of electrical safety, it is also important to consider the human factors involved. Proper training and education of healthcare staff on electrical safety procedures can help prevent accidents and ensure a safe working environment. Clear and concise signage should be used to identify electrical hazards and provide instructions on how to avoid them. Regular safety audits and inspections can help identify potential hazards and ensure that electrical safety protocols are being followed. The integration of all these elements circumflex technical design, equipment selection, maintenance practices, and human factors circumflex creates a robust and comprehensive approach to electrical safety in operating rooms and anesthetizing locations. This holistic strategy minimizes risks, protects patients and staff, and ensures the reliable operation of critical medical equipment. Continuous improvement and adaptation to evolving technologies and best practices are essential to maintaining the highest standards of electrical safety in these vital healthcare environments. Furthermore, the role of qualified electrical professionals cannot be overstated. Engaging experienced and certified electricians and engineers who specialize in healthcare electrical systems is crucial for ensuring that all installations and maintenance activities are performed correctly and in accordance with applicable codes and standards. These professionals possess the specialized knowledge and skills necessary to address the unique challenges of electrical safety in operating rooms and anesthetizing locations. They can provide valuable guidance on equipment selection, system design, and troubleshooting, helping to minimize risks and optimize the performance of electrical systems. Regular consultations with qualified electrical professionals can also help healthcare facilities stay abreast of the latest advancements in electrical safety technology and best practices. This proactive approach ensures that electrical systems are continuously updated and improved to meet the evolving needs of the healthcare environment. In addition to qualified electrical professionals, healthcare facilities should also establish a dedicated electrical safety committee. This committee should be composed of representatives from various departments, including electrical engineering, facilities management, nursing, and administration. The committee's responsibilities should include developing and implementing electrical safety policies and procedures, conducting regular safety audits, investigating electrical incidents, and providing training to healthcare staff. The Electrical Safety Committee serves as a central point of contact for all electrical safety matters, ensuring that electrical safety is a priority throughout the healthcare facility. The committee can also collaborate with external organizations such as electrical safety associations and regulatory agencies to stay informed of the latest developments in electrical safety and to share best practices. The integration of qualified electrical professionals, a dedicated electrical safety committee, and a comprehensive electrical safety program creates a strong foundation for electrical safety in operating rooms and anesthetizing locations. This multifaceted approach ensures that all aspects of electrical safety are addressed, from technical design and equipment selection to training and education. By prioritizing electrical safety, healthcare facilities can create a safer environment for patients, staff, and visitors. Continuous monitoring, evaluation, and improvement of electrical safety practices are essential to maintaining a high level of safety and preventing electrical incidents. This commitment to electrical safety demonstrates a dedication to providing the best possible care in a safe and reliable healthcare environment. Finally, it is important to remember that electrical safety is an ongoing process, not a one-time event. Regular training, inspections, and maintenance are essential to ensure that electrical systems continue to operate safely and reliably. By prioritizing electrical safety, healthcare facilities can create a culture of safety that protects patients, staff, and visitors. The commitment to electrical safety is an investment in the well-being of the entire healthcare community.